Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and this is our second video on factorising quadratic expressions. We're going to use what's called the difference of two squares here. Let's start by asking some sum and product questions. Pause the video and make sure you can answer all the following questions nice and easily. Okay, hopefully you got the following answers for these. And did you spot a pattern? Well, in the case when we're answering the question sum to 0, let's say, and have a product of negative 64, the answers are always going to be negative 8 and 8. So one's negative, one's positive, and they're the same size number. And this is a special case of that. And we're going to need this skill throughout this video. So make sure you're super good at these. The next thing I need you to think about is what happened when I asked you to expand things like this. Look back in your expanding section if you're not sure, but I would expect you to know. Pause the video and expand the following four things. Well, I really hope that you spotted that we have a bracket multiplied by its conjugate. And so the answer is x squared subtract 2 squared, which is x squared subtract 4. It's another bracket multiplied by its conjugate, so the answer is x squared subtract 25. Here, x squared subtract 49. Here, x squared subtract 121. And I pointed this out to you when we were expanding brackets, and I called it the difference of two squares. And I wanted you to spot that when you've got a bracket and you multiply by its conjugate, you get the first term squared, subtract the second term squared, 2 squared, which is 4 here. Now what this video is going to be about is it's going to be imagining that you were given the expanded form, and we're asked to put it back in brackets. I need you to be able to spot that I've got something squared take away something else squared. In this case I've got x squared take away 2 squared. And going backwards, factorising, I would expect you to think to yourself, right, either spot that's a difference of two squares, so it must be x add 2, x subtract 2. It's got to be, because you know a conjugate multiplied by a bracket is always going to give you the first term squared subtract the second term squared. Or you can look at it as we looked at these in factorising expressions 1 skill. You could think of yourself two numbers that, well, we've really got x squared add, we've got 0x here, take away 4. You could think of it as two numbers that have a product of negative 4 but sum to 0. And they've got to be 2 and negative 2 like we did in our starter here. Okay, so either way you spot that's a difference of two squares and just say x plus 2x subtract 2, or you think there's 0x, so we're product of negative 4 sum into 0. Here you could either think product of negative 25 sum to 0, so it must be 5 and negative 5, or you could think of it as I know that's x squared take away 5 squared, so I know it must be x add 5, x take away 5, because it's a difference of two squares. And similarly in all these cases here. Ideally, to be honest with you, I want you to spot that this is just a difference of two squares. And we've talked about these before. I have previously shown you when you have x subtract y multiplied by x add y, a bracket multiplied by its conjugate, and you multiply that out, you can just say it's the first term squared subtract the second term squared. And that's when we are expanding. But I also want you to be able to, if you see something squared take away something else squared, I want you to be able to put it into the bracket straight away and factorise it as x plus y, x subtract y. So this result, I just think it's going to come up so much in maths, you just might as well know it and get familiar with it. So let's try some questions on that in that regard. Pause the video at each stage, have a go yourself. Pause and have a go at these. Okay, the way I'd like you to do it is I'd like you to say, well, I know that's x squared subtract 3 squared. And I know that's a difference of two squares, so it must factorise to x add 3, x subtract 3. Simple as that. Next one. I know that's a difference of two squares, that's a squared, this is x squared, and this one is take away 4 squared. So it must factorise as x add 4, x subtract 4. Now you could write them the other way around, x subtract 4, x add 4, it doesn't really matter. The next one. Straight away I want you to spot that's x squared subtract 9 squared, and I want you to therefore factorise it as x. Let's put the takeaway first from now on, x take away 9, x add 9. And the last one, you need to know your squares. 225 is 15 squared, so this is x squared subtract 15 squared, so therefore it factorises to x subtract 15, x add 15. Simple as that, and we're done. Next set, pause the video, have a go at these. Well, I've just swapped the role of x and the number, but it's exactly the same format here. This is just 3 squared subtract x squared. A difference of 2 squares, a difference of 3 all squared, take away x all squared. So this must factorise to 3 subtract x, 3 add x. Simple as that. Next one, this is 4 squared subtract x squared. So therefore this must be 4 subtract x, 4 add x. And I'm sure you get the pattern with these. I'm just going to write these out straight away. Hopefully you got that. And the last one, we're going to get 15 subtract x, 15 add x. And we're done. Next set, do pause, have a go. Well, I just wanted to show you it didn't have to always be x, it could be other piece of algebra a, b and c here. Now you should know 169 is a square number. It is 13 squared, so this is 13 squared take away a squared, a difference of 2 squares, so we could factorise that as 13 subtract a, 13 add a. Simple as that. Next one, 196 is 14 squared, so this is b squared take away 14 squared, and knowing your difference of 2 squares, this must be b subtract 14, b add 14. And the last one, well, 1 is 1 squared, so we could think of that as c squared take away 1 squared, which will factorise as c take away 1, c add 1. Simple as that. Okay, what about these? Pause and have a go here. I've been a bit tricky here. See if you can work out what I'm doing. Now, 2, 5 or 11 aren't square numbers, but you can think what squares to 2. What squares to 2? Root 2. So this is just a bit tricky, just a bit harder for you. This is x squared subtract root 2 all squared. Root 2 squared is root 2 times root 2, which is 2. So this, if we were at a push forced to factorise it, we could say it's x subtract root 2, x add root 2. Similarly here, 5 is not a square number, but we do know what squares to 5, root 5. So we could write this as x squared subtract root 5 squared, and we could say this is x subtract root 5, x add root 5. And the last one, same old stuff. I think you get the message here. This would go straight to x subtract root 11, x add root 11, and we're done. Last little problem for you. This is a nice little puzzle we can use difference of 2 squares to solve. Pause and see if you can do it yourself first. Now, it says by writing this as a difference of 2 squares, evaluate it. Well, 102 squared subtract 98 squared. We know it's something squared take away something else squared. We know our rule from before, our difference of 2 square rule. We know that x squared subtract y squared. We can factorise that as the following. So we could factorise that as x subtract y and x add y. We know that rule. That's our difference of 2 squares rule. So let's try and apply it in this case here. We could say 102 squared subtract 98 squared. Well, we could say, well, that's 102 take away 98 in one bracket multiplied by 102 add 98. Now 102 subtract 98 is 4, and 102 add 98 is 200. So this must be 4 times 200, and God, that's dead easy to work out. That's just 800. So who would have thought 102 squared subtract 98 squared we could work out so quickly without having to go and do long calculations? And this was a nice little use of difference of 2 squares with numbers. That's it for this video. Thanks loads for watching.